Okay guys, this is our last lesson for the unit, and just a couple warm-up questions here before we start. These are similar to the homework questions we had. The first one says, sketch a possible graph given the following domain and range. This is good practice to show if you really know and understand what the domain and range represent. So the first one says, if x is less than or equal to 3 and y is greater than or equal to 1, sketch something that fits those dimensions. So you can imagine if it's less than or equal to 3, here's 3. If I'm less than, it means I'm on the left side of 3. So there's kind of an imaginary divide here that separates so that you cannot have anything on this side. So that's one way to think of this. Then it's also y is greater than or equal to 1. So here's 1. So what that's saying is that, again, imaginary divide here, I must be on the upper side or the positive side of that, greater than or equal to 1. So any graph I create has to fit in here. And it also has to be less than or greater than, so it needs to kind of start, or a couple options here. Easiest thing is to start in the corner, and let's say it just keeps going up and to the left. You can have any variation of this. It could be going up there, as long as it keeps going. So putting arrows on the end is a good idea. So in this case, when you think of this, would this be a function or a relation? The thing I've drawn is a function because it passes the vertical line test. The next one, again, if we're greater than or equal to -4 this time, so here's -4, it means I'm on the right side of that. It also says that y is all real numbers. So that means I have to touch the -4 at some point, doesn't matter where, and I have to keep going up and down. So something like this. So any variation of this, you could have your guy go like this if you wanted to. As long as it continues up and or down and up and to the right, then you're good. In this way, there's no way to create this thing and make it a function. This was one of the questions in the homework, and it's actually kind of a trick that they threw in. But you can't have a function here fit these parameters, so this is just a relation, not a function. So that was one part from last lesson. The other part was function notation, and that's where we say things like this. It says determine f at -5, and again you can just try this on your own. So all I want to do is replace x with -5 wherever I see x in my function here. So I've got 2 spots I need to put it in, and then I can just simply evaluate and simplify. So we end up with here 13 times -24, and you can punch that into your calculator and you should get -312. So again, this is my value of the function at -5 is equal to this, which is really just a point on the graph of that function. The second one's a bit trickier. It says find x if I know that this, the function, is equal to 0. This means my y value is equal to 0. So what I'm going to do is I'm going to replace f at x with 0. Because it's equal to 0, we've seen this before in the last unit, really to solve for x, I need to figure out what would make this be 0 for x in order to equal the left side, and what would make this equal to 0. This is just solving a quadratic, and so I set it up equal to 0, and I solve for x. So I end up with positive 3 over 2, and then this one is -1/5. So really I've got 2 points here, or 2 answers to this one, which is 3 over 2 comma 0 and -1/5 comma 0. Those are my x-intercepts. Okay, today's lesson we're looking at and revisiting the optimal value or the maximum minimum stuff, but we're looking at strictly optimization in a word problem or application problem. So when we're solving for the optimal value, remember the optimal value really just means we're looking for the y value. So in a question, it might say to find the maximum or minimum, or it might just say, find the value of x when that happens. So if we're doing this, there's two ways we can do it in order to find that max or min or the vertex. If it's in standard form, then we can complete the square. Which gives us the vertex form, or we can use the axis of symmetry, which is our negative b over 2a, and we can sub that in if we need to find the y value or the optimal value. So the tricky part in these questions is actually just setting up the equation. So we're strictly going to look at three types of problems. And the more familiar you become with each type, the easier you're going to be able to predict and figure out how to come up with the equation. So let's look at these few. So the first one fits into the category of an area problem. And so it says Farmer Joe wants to construct a rectangular field along one side of his barn. What that means is that if he has 100 feet of fencing and one side of the field does not need fencing because it's enclosed by the barn. And then it says, what are the dimensions of the largest rectangular area? This is another way of saying the maximum. So if I just do a little sketch of this, so let's imagine this barn. And you'll laugh at my drawing. So maybe it looks like a clown tent, I don't know. Here's my barn. What they're saying is I've got a field that's coming off one side of it. And so I don't need fencing for this side because it's enclosed by the barn. So if it's rectangular, it means that this side and this side are the same. And this one's going to be different. So I'm going to call this X, let's say, and this one side Y. So we say let X and Y represent the sides of the barn, or side lengths. So, two things to think about. If I want fencing, so I want this fence, and this fence added up to be 100. That is involving the perimeter. So these questions will always involve the perimeter and the area. So the perimeter, I know that I want 100 feet of fencing, and I know that that's going to be equal to all of the side lengths added together, so 2x plus y. I can rearrange this equation, so I've got y equals 100 minus 2x. So that gives me an equation I can work with. The other part, the area here, is just simply one side times the other side, or length times width, so it becomes x times y. What I'm going to do is take this equation and I'm going to replace y in my area here. So I'm going to sub this in. So let's call this equation 1 and this equation 2. So I'm going to sub 1 into 2. So I get the area is equal to x times 100 minus 2x. Notice now I have no y's left in here, and I can use this in order to figure out what x is. So I multiply the x through, I get 100x minus 2x squared. So again, it wants the largest maximum area. So if I set this up, I want to find the maximum here. So I'm going to find the max, or at least the x value of when that max occurs. So in order to do that, I need to find the axis of symmetry. So that's our negative b over 2a. So if I take this, watch, this is my b and this is my a because it's got the squared term, so that's a. So I've got negative 100 over 2 times negative 2. So that's negative 100 divided by negative 4, and that becomes 25. And that represents, because I had x here, this represents my x value for this dimension. So I already know that that's 25 feet. And the second part is to just figure out what y is. So if I had got 100, and we've got this equation here, I need to find y. So I got 100, or y equals 100 minus 2x, which is 100 minus 2 times 25. 100 minus 50 becomes 50. So therefore, the dimensions are 25 and 50 feet. And that's it. All of these questions that involve area and perimeter are going to be the same. You have to use both and take some sort of equation and sub it into the other one, and then use your axis of symmetry to figure it out. Second one, we've kind of seen something similar. It says two problems, and this is a number problem, and you'll have a couple like this. Two numbers have a difference of 8. Find the numbers so that their product is a minimum. So let's say I have, I don't know, y minus x equals 8. So the difference between them here is going to be 8. So that sets this up. So I can rearrange this equation. So I've got y equals 8 plus x. So I can set it up like that. The other part says that the product is a minimum. So remember, product means multiplication. So my product, P, is going to be x times y. So what I'm going to do again is replace, in this case, y with 8 plus x. So I've got x times 8 plus x. I can simplify that, so I get 8x plus x squared. And now I want to find the minimum. So again, first thing I need to do is find the axis of symmetry. So if I sub these things in, 8 being my b, so I've got negative 8 over 2 times 1, so I end up with negative 4. That's my x value, because this is what it had in an equation, was x. So my first number is going to be negative 4. Therefore, if we do the second part, I've got to find y, my second number. So I got y equals 8 plus x, and I'm going to sub in negative 4. So I end up with positive 4 for y. And that's it. My two numbers that produce a minimum are negative 4. So the two numbers are negative 4 and 4. Okay, that one's not too bad. The last one, it can be a bit confusing, but we're going to set it up so hopefully it makes sense to you. So it's just, these are profit or revenue problems, and you've probably done one like this last year. It says, we've got a 300-room hotel in Las Vegas, is filled to capacity every night at $80 a room. For each $5 increase in rent, 3 fewer rooms are rented. So as it goes up, they rent less rooms, but they make more money. So how much should the management charge for each room to maximize the gross profit? So, and then it says, what is the maximum gross profit? So how much should they charge? So how much do they want to figure out here? So the first thing we're going to do is, we don't know how many times they're going to increase the rent and then lose 3 fewer rooms. So that's our variable, and that's always going to be the case. So let's say let x represent the number of increases, or of price increases. So when you do these questions, profit or revenue, so profit is always going to be considered price of what you sell times the number sold, or number rented in this case. So we've got the price of the rooms times the number rented. So we need an expression for price and an expression for rented, the number rented. So when you set these up, you're always going to have these two things multiplied together. When I go back through and I read the question again, and as I read it, I say, okay, what part does this go in? So a 300-room hotel in Vegas is filled to capacity. So does that 300 fit into the price or the number rented? So hopefully you figure out number rented. So I'm going to put 300 here. And it says that's at $80 a room. So $80 is part of my price. So I put 80 bucks here. And then it says for each $5 increase. So again, $5 increase in rent. So that's part of my price. So I'm going to say I'm increasing it. So it's 5. But I don't know how many times I'm going to increase it. So I'm going to put my X there. And then every time I increase it, I get 3 fewer rooms. So that's the number of rented. So minus 3X. And that's it. That gives you your profit expression that has price times the number rented. And because it's a function, I'm going to write it as P of X for profit of X. So what we need to do is now FOIL this out. So 80 times 300 plus 80 times negative 3X and so on. So you can try that. So I'm going to write it out just to save some time. So this 80 times 300 gives me 24,000. Minus 240x plus 1500x minus 15x squared. Then we can just collect like terms. So I get 24,000 plus 1260x's minus 15x squared. So this gives me an expression that I can now find the maximum for. So I want to find maximum. So again, two options. You could either set it up so you've got your axis of symmetry or complete the square. So I'm going to do axis of symmetry, which will give me the x value. So negative b, so b here is 1260, over 2 times a is negative 15. Oops. 2 first. So if you punch that into your calculator, you get x is equal to 42. That means in this case, x is the number of price increases, so I have 42 price increases. So the price of the room here is 80 plus 5 times those 42. So I've got 80 plus 5x, and I sub in my x. So I end up with 290 bucks. And the maximum profit, so that means I want to get my whole overall profit. So this was number 2, and now we're at the third step here. P at 42, I need to sub in 42 in for x to my original equation. I'm afraid I'm going to run out of room here. And so we know the first thing here works out to 290 because we just did that. And then 300 minus 3 times 42 gives me 174. And you work that out and you end up with $50,460. So therefore, max profit is this 50,460, and the price of the room jumped up huge from $80 to 290 bucks a night. Okay, so if you need more help, look at the notes to see how to fill in these ones. So everything's filled in online. Otherwise, please come in and see me. Talk to you later.